Hello and welcome back to the third video in this series where together we'll learn Prolog. In the very first video we just dipped our toes in and did the very simplest thing we could do, which was to create simple facts and query them. In the second video, the last one, we introduced the idea of variables, essentially asking Prolog which values for a variable could satisfy a query, and that was very useful. And we started to think about how Prolog goes and finds answers, and the mechanism of backtracking and unification, which we'll come back to, so don't worry if that was a bit overwhelming. Today we're going to just take again this idea a little bit further, the idea of properties and facts in the database, and we're going to just very gently nudge our complexity a little bit higher, not too much. On the screen is example 3. You can find all the code on GitHub, and this example 3 should look familiar because we are talking about fruit again, things called apple, banana, cherry, apple, cherry, grape. And in the first bit of code we are saying that apple has a property called tasty, banana has a property called tasty, and cherry tasty. And in the next bit of code we're saying that an apple has a property called red, cherry red, grape red. Essentially we're saying that apples, bananas and cherries are tasty, and apples, cherries and grapes are red. There's a slight difference here. You can see that apple is common, banana is tasty, but there's no mention of banana here because it's not red, and a grape here is red, but it's not mentioned here, so we can't say it's tasty. It might be, but you remember that in Prolog, if Prolog can't prove something based on facts, it can't say it's true. So let's just test that just as a refresher. Let's say red, tasty, cherry. We know that to be true, and that's true. And if we say grape, well, we expect it to say no, because it can't prove that a grape is tasty, because there's nothing in the database that tells us that. The only thing about grape we know is that it's red. And let's just remind ourselves of the variables. So tasty, we could say X or Y or F or fruit. As long as it begins with a capital letter, it's a variable. So we're asking which things are tasty. So apple, fruit, banana and cherry. It's just a bit of revision. And the same with red. We're asking which things are red. Apple, cherry, grape. Great. This is just revision. This is all the stuff we did last time. Now let's ask ourselves about satisfying more than one property at a time. So let's ask which things are both tasty and red. So we're asking, in a way, we're asking tasty X, but we're also asking red X. We're asking for which X are both of those things true. And the way we do that is by using a comma. A comma in Prolog means and. So it means this and this is true. So if you want to speak the formal language of logic, that's a conjunction. But don't worry about that if you're not familiar with that word conjunction. So this is simply saying, this is the question we're asking Prolog. We've got a more sophisticated query now, and we're saying which X makes tasty true, but also which X makes red true at the same time. So we are asking Prolog to satisfy more than one property, and that's an important and useful thing to be able to do. So let's run this. So it says apple. let's check that. Apple is tasty, yep, and apple is red. It's suggesting that it might want to carry on searching for another solution, so let's say yep, go ahead. Cherry. Cherry is tasty and cherry is red, and there's no more. And that makes sense, because banana isn't red and grape isn't tasty. So that might seem like a simple thing that we've just introduced, but it is an important kind of foundation for Prolog, being able to satisfy multiple properties. We didn't have to use variables, we can dial it back down and say tasty apple and red grape. Is that true? So are both of these things true? And we know that should be true. Yep. But if we say red fish, we know that that bit can't be satisfied. So even though tasty apple might be true, this isn't, because the comma means and. It means both have to be true. So that's false. So that's a useful experiment to do just to see what's really happening. So red fish isn't true, tasty apple is, but together this entire query is false because the second part, it can't be satisfied. We can ask a variation of the earlier question. We can say apple is tasty and tell me all the things that are red, which isn't that interesting because this is true anyway, and that's not different from asking just red X. By the way, you can hit these buttons which say continue for the next 10, and there's only 3. Fantastic. So you could pause there and stop, but let's think a little bit about how Prolog finds those answers. To do that, you can go to the blog and you'll see one of those pictures again, the kind of search trees. I'll talk through it this way and then I'll talk through it a different way, because this way of explaining it might help some people and the other way of explaining it might help others. So we start with the query tasty X red X, and Prolog will work through left to right in a multi-part query. So our query is tasty X, comma red X. That's the query, and it has 2 parts. The first part is this one, and the second part is that one, and there's a comma to say both have to be true. So it will deal with Prolog will work left to right. Just a bit of colour, left to right. So it'll deal with that one first, and then that one. So moving left to right, it will work with tasty. It'll look at that first. So tasty X becomes its goal as it tries to find the overall solution. It will split the problem into smaller problems called goals. So the first goal is tasty X. That's very similar to what we looked at last time. And it'll look in the database to see what can be unified. Remember unified? Matching and unification. What can be unified with X? Tasty apple is in the database, so X equals apple satisfies at least the first part of the query. It satisfies the first goal. It can't say X equals apple is definitely the solution, because it might not satisfy the second part. So that's why we've put a dotted box around it to say that's a candidate solution. So up to this point, it's found tasty X equals apple works. So that's the left hand side, the first part done. Moving right to the next goal, red X. That's the next goal it has to do, but it's got X already as set to apple. So red is not red X, that's the goal, it's red apple, because X has been set to apple. So can this be satisfied? Well, it's in the database, red apple is in the database, so it's true. So X equals apple moves from being a candidate solution to being a proper final solution. Rewind that if you need to, or read the blog where it's explained step by step. But remember, Prolog wants to find more solutions, so it backtracks all the way up here to where X is unset. Tries again. The first goal is tasty X, and it's already done apple, the first item in the database. So it'll try the next one, tasty banana. Does that unify tasty X and tasty banana? It does. So X equals banana is a candidate solution. Again, it can't say it's a fully confirmed solution because it might not satisfy the second part of the query. So X equals banana, let's carry on. Tasty X is now satisfied with X equals banana. The next goal is red X. X has been set to banana, so red banana. But there's nothing in the database that confirms that. Red banana would be false. There's nothing in the database that tells us that's true, so that's false. So this is an interesting example here where it found an X which satisfies the first part of the query, the first goal, but doesn't satisfy the second. So we found a candidate solution, X is banana, but then we didn't go forward with it because it can't satisfy the second part of the query. Everything in the query has to be satisfied. So you go back to the beginning, backtrack, and we try again. Tasty X, working left to right. And the next thing in the database to try is tasty cherry. X equals cherry, that's a good candidate solution. That satisfies tasty X. Will it satisfy the second goal, red cherry? It does. So we have confirmed two solutions. Let's go back and see whether that was true. Tasty X, red X. There were only two solutions. That's it, apple and cherry, but not banana. Fantastic. So that's one way of explaining how that works. What I'll do is I'll draw a picture to illustrate the same idea in a different way. Right, so we have a query, tasty X, comma red X, comma means and I've just copied over here the database of facts, and I'm just going to kind of work through how Prolog finds the answer in a different way. So it works left to right, so it starts with tasty X, so let's write down that. Tasty X, that's the first goal, and it tries to satisfy that first. And to do that, as we know, it looks through the database, works its way down, trying to find values for X, and it does that by matching, unifying. And we can see here that the first item, tasty apple, will match and give us X equals apple, if I can spell apple. So that's our first solution, or to be more precise, our first candidate solution. So X equals apple is a candidate solution because so far only the first part of the query has been satisfied. The next part of the query, red X, also needs to be satisfied. So we carry on with X equals apple. Red X becomes red apple because X equals apple. Is that true? Yes, we found that in the database, so that's true as well. So that can be promoted to a full solution. X equals apple is full. It doesn't stop there. Remember, Prolog backtracks and tries to find more solutions. So go back to tasty X again, where X is unset. I'll choose a different color. And it looks through the database. It's already tried apple, so let's try tasty banana. So X equals banana satisfies tasty X. Would it satisfy, so that's a candidate solution for now. Would it satisfy red X? Let's see, red X, which is now banana. Is that in the database? red apple, red cherry, red grape, but no red banana. Can't unify with any of these, so that doesn't work. So the solution is rejected, the candidate solution. Go back to the beginning, and this time we're back to tasty X, and we'll try again. We've done tasty apple, we've done tasty banana, let's try tasty cherry. So X equals cherry, that works for the first part of the query. So tasty X, tasty cherry works. Does it work for red X, where X now becomes cherry? Red cherry, yep, that's in there, so that can be promoted to a full solution. So that's just another way of kind of talking through the same mechanism for how Prolog works. So that might sound quite complicated, it might sound quite involved, and I want to just tell you that actually you don't need to get it the first time. Take your time, read through the blog, rewind the video, see it several times if you need to. So the point is not that you understand how that works the first time, but you will need to understand it eventually, because that's how Prolog works, and understanding how it finds answers, how it finds solutions to our queries is important, because that helps us write better programs and better queries to take advantage of how Prolog works. So although it might have seemed quite a simple thing to do today, you know, kind of querying multiple properties, satisfying multiple properties together, actually we've exposed a little bit more about how Prolog works. So I'll stop there, and we'll continue next time with another topic which extends our understanding of Prolog. So see you next time. Bye.